And it was all my silly fault. Okay, so I think audio is working. It should be, yeah. It's because I screwed things up last week. When I was last week working from my laptop, I unplugged a bunch of stuff, changed it around. I had the receiver for the radio mic plugged into the wrong socket. There are two microphone inputs on the 8M, and I had it plugged into mic 2 instead of mic 1, and mic 2 had its volume down. That's why I couldn't figure out the audio. Stupid things can totally throw me sometimes. Just dumb things. Yeah, it's the classic "is it turned on" sort of situation. But hopefully now audio is working. So that means that I can do this. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today, or in the barbecue subsequent to the live stream. Actually being physically on site, on country. So, thank you. Audio is working, yes, good. Thank you, Amanda and Stephen. Where is the button? I don't know. I am going to be in turbo mode today because today is barbecue day. And I am totally unprepared because I was working on work stuff through the last 2 weeks. Have been kind of insane, working into the night every night, and handed over some stuff to it's working. Johnny Bergdahl. my hot Swedish friend. 33 months of membership. 2 years, 9 months. I didn't have the volume turned up high enough though. Thank you, Johnny. So, yeah, Andrew says we've been doing video conferences for a number of years now, but still everyone starts with "can you hear me?" and more likely a mouth moving, people typing into chat, "we can't hear you." Yeah, I know, it's a thing. So where was I? That's right. The result is the loading dock area in the front of the workshop where I need it all clear for the barbecue to be set up. It is not clear. It is full of stuff. The Bernie Boy is out there, the Bernie Boy 7000, the old reflow oven, plus 3 table frames and some other miscellaneous things. It's all piled up, jammed out there. I need time to prepare. My usual plan is to do all of the preparation for the barbecue the day before, so I usually spend the Saturday doing clearing up and preparation, but I couldn't yesterday because I was working until late in the day, very late. And then I came in this morning, did some preparation, went to the shops, bought a whole heap of food yesterday as well. So I'm prepared in terms of having the stuff. I just don't have the room to have the people to have the stuff. My point is, I am going to do a 1-hour live stream today, and we are already 8 minutes into it. We are past 10%. We're at about like 12% of the live stream already. What? Okay. Mitch says, mime type application / John. Yeah. Yes. So I am going to turbo through something and maybe I've got to make progress on the conveyor. So I think we should do that today. But first, good morning to Mitch, Stephen W, Amanda, Henrik, Stephen W again, Grant Maisels is here, Keith H, Barbecue Keith, Stephen George, Crispian, Any Mule, Simon, Imi. I think Crispian and Imi are probably in a car right now, traveling. Andrew Ruthven, Russell Rennie, Johnny Begdal, 33-month Johnny. So anyway, I need time to actually make some space before everybody starts arriving. So my goal is to, where's the button? There's the fusion button. Austin says, I'm here listening and trying to bodge a PCB wire. Ah, okay. That is obligatory. If there is ever a design that works without a bodge wire, then I think there is like a moral obligation to find a reason to add a bodge wire. I am just opening Fusion. So, yeah, Grant said consequences of outside broadcast last week. That's it, exactly. Today's live stream will be in Braille. Just resizing that and getting this. I know you can't see what I'm doing right now, but I'm getting there. That's because I'm in a client folder and I'm getting out of it into Superhouse projects. Conveyor 3. That. Soon you will be able to see it. Okay, let's see. But while I'm doing this, what, Mitch asked what color wire. It, sorry, I should translate what color wire, but without the U for the USians and Canadians in the audience. So Austin said, some silly product manufacturer designed an NRF-based BLE panic button key fob, but decided not to add a connection to the ADC to know when to replace the battery. Oh, okay. So was that silly product manufacturer you? Gerald42 is here. Good morning, Gerald. Yeah, so bodge wires. They are required to be green. There is no other possible color for a bodge wire. They have to be green. Oh, Austin says it was not me. Okay. So it's just a feature of the thing that you think it should have, but it does not have, therefore you are going to retrospectively make it have. Is it a... What this means, though, obviously, is that you are having to do something to the firmware to make this functional. Otherwise, doing a bodge wire is not going to do anything, unless the firmware already had support for battery sensing through the ADC. Okay, so if you are checking the voltage on the battery through an ADC, that means that you are probably running a voltage divider, is my guess. Oh, Simon said, mine are always blue, using an old roll of Teflon coated wire wrap wire. Yeah, well, blue is an acceptable alternative. By Any Mule says, bodge wires should be color coded to the PCB so they look like part of the design. Yes. In fact, there were some boards that I did for a client about 2 weeks ago, and the PCBs were black solder mask. And so I used black wire wrap wire to do a tiny little bodge wire. And the bodge wire happened to be fairly close to a location where there is normally Loctite gel glue put on the board as a mechanic, like an anti-vibration thing for a capacitor or something that was in the general vicinity. So what I did was just sort of make the glue a little bit bigger and you can't even tell the bodge wire is there. It's black bodge wire on a black PCB. Oh, Imi says, we just drove past Tullamarine and saw a plane on final approach. Yeah, there's a spot, it's a long time since I've been there, but there used to be a spot where there was a road that ran right around the perimeter of the airport at Tullamarine, and one of the runway, the end of one of the runways was right behind the fence, and you could drive your car up and a whole lot of people would drive up and park on next to the fence, and planes would come in and right over your head and land on the end of the runway. That was pretty cool. But it's a long time since I've been there, so I don't even know if that road is still there or anything has changed. Pete, wake up, Pete. Pete is here. Oh, and some call it fun is here. Hello, some call it fun. Hello, Pete. So putting the call out again because I still want to figure it out. For those of you who were regulars at barbecues like a year ago to 8 or 9 months ago, I am still trying to find the guy who brought along a couple of 24 gigahertz or whatever they are, radar presence sensors, whose name I think is Dave. I could be wrong, but I think it's Dave. And he used to be a regular at the barbecues, stopped coming, and I have not had any contact with him since. And I want to get in touch. So if anybody can figure out who I'm talking about, maybe maybe Stephen remembers, I don't know. Because, oh, David. Hi there, it's me. Ah, okay. I was wrong on the name. Yes, Dave, that sounds right. Yes. So, Mitch says, sorry man, Dave's not here. You know, I have seen the clip of that. And I don't even know what show it's from, but the guy running from the cops, banging on the door saying, hey, let me in, it's Dave. Dave? You want Dave? Dave's not here. No, this is Dave. David Howes, if that is you, I still have your radar presence sensors. Oh, that's what it is. Okay. And I've been wanting to follow up with doing a thing about it, but I didn't want to do that and not give credit to the right person and all that sort of stuff. So anyway, I have been sitting on your radar present, not literally sitting, but I have been holding off doing anything with your presence detectors for all of that time. Because, yeah, anyway, I hadn't seen you for a long time. But it's good to know that you're still good. So that's cool. So where are we? Conveyor controller. Yes. Okay. So conveyor controller. I did a little, hang on, cough incoming. Ah, oh, that's better. A bit of iced coffee to go with the cough. Okay. And a little bit of a cry as well. I don't know why, just from coughing. Yeah, so during the week I messed around. In fact, I think it was last weekend after the live stream even, I did a bit of messing around with this design and made a few rationalizations. So I did a couple of things. JK Electrical says, is it too late to come along today? No, it's not too late. Not unless, hang on, not unless you are coming from more than about 3 hours away. So, sorry, I just got a, I was just seeing messages. Yes, Pete is trying to ping me through back channel on SMS, and then I saw that there were other messages as well. Now, I may be able to get rid of this I/O expander. That, and also I may be able to get rid of a couple of other things. I don't know if I still want the display. So the 30-second refresher is that what we have here with this schematic that you're looking at right now and with this board is an amalgamation of the previous version of the PCB controller and what did I bring in? Maybe part of the rack 32? Something like that. Anyway, I merged Oh, okay. Pete says, I didn't send no SMS today, lies and defamation. Okay, it probably wasn't an SMS. Are you being a lawyer, Pete? Maybe it wasn't an SMS, maybe it was like a Facebook message or something. Okay, JK Electrical, great, where do I find details? Details are... Oh, okay, here I go, doxing myself. If you go to... Ah, yes, Keith has just... Keith has just said it. You know, this is one of those things where... okay, squirrels. I may not even get to this design today. So, JK Electrical. The details are at superhouse.tv, so at my website, and I deliberately added some words there in the middle, and then you add /BBQ on the end. Oh, Austin put the URL in there. I was deliberately not saying the URL so that text-to-speech would not convert it into a string that could be then searched, could then be discovered. So, you know, okay, this is the squirrel. A long time ago, when, how old was I? I can't remember. It was a very long time ago. I must have been young when I read The Mote in God's Eye, I think, was it? So there was there's a series of science fiction books called, it's referred to as like the Mote series or something. Austin? No, don't worry about it. That's all right, Austin. I think it was yeah, anyway, it was Larry Niven and Jerry Pournelle wrote several books, and the premise was, yeah, Gerald42 says Jerry Pournelle. Yeah, I think it was Jerry Pournelle and Larry Niven. They collaborated, or maybe they collaborated on the sequel or something. Anyway, there were several books. This is a whole lot of setup for something that is actually really trivial, a tiny little point, referencing back to the barbecue URL. Now, in these books, it is about first contact between humans and an alien species. And these aliens are referred to as motes. I mean, none of this is relevant, but I'm just telling a story. Because the star system they come from is a blemish. Like when you look at it from the point of view of Earth, it's a blemish in a constellation called God's Eye. And so it's called the Mote in God's Eye. And and so the humans just refer to them as motes, the aliens that live at this particular location. And yeah, Gerald42 says, great book. Yeah, there are some very interesting things in it. But one of the things that I remember from the book, I just remembered recently, is when they are making first contact. So there is an expedition of humans who go to the location, to the moat. Wagon Loads is here too. They go to the moat, visit the motes, and prior to the actual meeting, so they know that they can't communicate. I can't remember the details. It is literally decades since I've read the book. So this is going from memory. I may be totally wrong. They know that the motes don't understand human speech. And so it's this meeting of two groups who can't communicate by voice. And so in one part of the briefing, before they go in, there is this tiny little thing. It's only like a throwaway thing. It's not a major point, which is they in the briefing they said, do not say anything in front of them that you don't want them to hear or understand, because it will be recorded. You can guarantee that everything that happens is going to be recorded, and later, when they figure out human speech, they will retrospectively be able to interpret and understand whatever it is that was said at that first meeting, even though they can't understand it in the context of the meeting. And that is very much how I feel about AI. And I don't mean it in the sense of AI retrospectively understanding. I mean AI retrospectively, or ML is a better way of putting it. ML tools retrospectively processing content that has been produced previously. If there is content out there on the internet, it has already been slurped up by as training data for LLMs. And so if you, for example, in the past were very careful to not publish your email address in text form on a web page because you wanted to keep yourself off spam lists, but you might have included the web address in a text form inside a video or in a photo and thought, oh, it's safe, that will never be processed. Or you might have said the email address. Retrospectively, that's all gone now. Like in terms of privacy, that's all gone, because text can be extracted from video and from speech, obviously text to speech. Now, this thing is what was I thinking? Brain misfire. Yeah. This video, if you sometime, like probably tomorrow sometime, this random video that is going to be me just rambling for an hour-ish, if you watch this video, you will be able to turn on subtitles. And miraculously, everything I say is going to be in text on the screen. And that's just a given these days. It's just the way things are. We have the ability to transmute one form of media into another. And any media that can be transmogrified, or whatever the term is, into text can be processed as text. So if you have any content on a video, in a photo, spoken, it will end up being ingested by LLMs. It's inevitable. It's going to end up as training data for AI. And yeah, so another way of thinking about it is anything. This is kind of a sad way of thinking about it. Anything that you think you have an expectation of privacy for now, you may not have an expectation of privacy for in the future, because it may become possible to crack strong encryption through various technological advances. It may be possible to take content that is obfuscated in a certain way and expose it. And of course we see these whole things now about captchas and a human trying to prove to a computer that you're not a robot. And how complicated they can be now, because in terms of puzzle solving and image recognition and all of those sorts of tasks, computers can be better than humans at it. So how do we prove that we are human when we are not necessarily even as good at doing basic things as the computer is? Austin says, well, the fact that there are states that wanted to create a law that said you couldn't make laws around AI tells you what you need to know about companies making AI stuff. Yeah. Okay, so, all right, a quick glance down the chat. Pete said, I've got the stuff. Okay, that's good for you. I don't know. Simon asked, any progress on the Test-O-Matic? That is one that I need to get back to as well. I sent the was it 805593 something? I can't remember the part number. I sent the modules. In fact, I have them. They're sitting on my bench. This is like right here. This is one of the little GPIO modules in its carrier. In fact, if I take it out, it's even smaller, and you wouldn't even see it. This is it right here. So that's the module sitting in a carrier to make it compatible with 0.1 inch pitch things. This is my bottleneck right now. So the reason that I do not have more progress on Test-O-Matic is support for this in Python, and I need to get back to it. I sent those to, God, blank on his name. Someone will remember it. I could find, is this a squirrel? Yes, this is a squirrel, to Braze. What's his name? The guy who writes all the libraries, every single library ever, every single Arduino library ever has been written by him. I can't remember. Anyway, I sent him a few, and I think he's been working on the Arduino driver for it. So I need to follow that up, see what he's done with the Arduino driver, and then implement, and then whatever he's done, implement my changes in the Python driver that I've got partly working. So, okay, that, yeah, that is a really big issue. There's a particular project. Anyone that comes to the barbecue today is going to see a heap of boards sitting in trays in the cleanish room for a project. This is the project that I have been busting myself on. Well, I've been working on it for 5 years now. This is the truck curtain project. I've already mentioned it, so it's no longer a secret. 5 years I've been working on that project. The last couple of weeks, that is the thing that I've been busting myself on till late in the night, because we are doing the first production batch of the device, and it is so labor intensive. And a major part of that is the process of flashing the firmware onto the devices and doing tests and pairing the controllers with the motors and all of that sort of thing. So getting the Test-O-Matic to a state where that can help me with that project is a really important thing, and I want to make progress with that. But it's been one of those situations where I can't take the time to stop and make the process better because I'm too busy working on the process, not fixing the process. Yeah. Oh, Lee, thank you. Lee said, in case no one has told you this week, we appreciate all the work you've put in your content for the last 10 years. Well, thanks, Lee. That's really nice to say. Sorry, some more people. Hello to Lee, to Braze, Tech Nebulous, Jax Tech, David House, Wagon Loads. Hang on, I'm tapping things in the TTS and it's not going away. There we go. Okay. I may never actually get to the thing. Wagon Load said, I asked Mojeek, what's Mojeek? Is that like a new LLM or something? I haven't heard of that one. About certain events, it only relies on information created by the liars of that event. Okay, I don't know what event you're talking about or what the lies are. I don't even know what Mojeek is. But I think the point is you can't rely on LLMs to be accurate or... Yeah, I think we're starting to see a lot of backlash now. There are people who have been skeptical from the start. There are people who have been true believers and are still true believers, and there are people who have had a moderated approach to machine learning in the context of like LLMs, and yeah, it's Anyway, that's a whole big subject. Simon, title of live stream, nothing but squirrels. Oh, Pete says, have you tried using an LLM to write the Python support code? Throw the device specs at the LLM, tell it what sort of Python support you need, see what comes out, etc. Yes, I actually have. Oh, Pete said, like, upload the device PDF. Or is that something that's considered a no-no? To me, the hardware spec is available to be examined. The language spec is available to be examined. It's fair game to use an appropriate language model. Yeah, I agree. And I actually, I actually used this as a test case. Maybe I should do this on a stream sometime. I have been... Cursor. Here we go. I'm just going to open something. Open project. Oh, okay, it's forgotten where everything is. One of the other things during the week is that the SSD, the external SSD attached to my computer died. And that SSD is what I have my Dropbox my Dropbox folder on. And everything that I have is in Dropbox. So the result is that all of the links, all of my, the paths to everything have changed, because what I did was I created a new Dropbox folder on the internal disk and resynced. But now IDEs have forgotten the locations of projects and all of that sort of thing. Hang on, I'm gonna go to, what am I going to go to? Okay, I'm going to go to Superhouse projects. I'm going to open the firmware for the conveyor. Why not? Let's do the PCB conveyor firmware. Firmware conveyor 2, PCB conveyor 2. Okay. Oh, it's not going to let me... Oh, hang on, open that. Will it let me? Oh, it is. Okay, yeah, I've never actually opened an Arduino project in this before. So it'll be interesting to see what happens. So this is not what I was using for that purpose. Jordan currently catching up at 3x speed. All right, so this is an IDE called Cursor, which is LLM backed, and like it's integrated LLM. It's based on VS Code, but then it does stuff. So, right roll. What's going on there? Oh, okay, yeah, that's it. But what it does is it it does inline assistance. It's got a chat over here, so there's an agent, and I can talk to the agent about the code. Kind of similar to doing the online AI stuff on GitHub with GitHub Colab or whatever it's called. But this is in a local IDE, which is then linking to a remote LLM, obviously, because I can't run the LLM locally. Jacksec says, so it's like Copilot. Yeah, kind of like that. And I'm just trying to think of something like, it just tries to, what do we want to do? What do we want to do? And I've spent very little time using Cursor. I've been experimenting with it a bit in an ESP IDF project. Actually, for the firmware for the truck curtain project, I normally code in Vim. That's just my standard environment. And I keep trying to force myself to use real IDEs, and most of the time I don't like them, and I just keep ending up back in Vim. So I've experimented the code for the truck curtain project I wrote with a large part of it was actually written by Angus. So Angus and I have been collaborating on it, and I don't even know I think he uses Emacs. I'm pretty sure Angus is an Emacs user, and I've been using Vim to do the ESP IDF stuff, and then I've just been trying to use this. Now let's try init Wi-Fi. I don't know, I'm trying to think of some to-do thing that I can just start typing to see what it does. Now, what I could do is, yeah, there are things that it does. It's set up. I'm not going to actually keep this. I'm just going to start adding a thing to demonstrate what happens. So perform state transition. Now, let's see. I want to do, let's see, stop all motors if, no, not the state change. You can see that it's trying to auto-complete there. If the state changes to an auto state, I'll say if the e-stop button is pressed, just tab to auto-complete. And you can see that I tabbed autocomplete to the end of the line. It has now just invented a function called check e-stop, and it says if digital read e-stop pin equals high, GX direction equals stop. And I can just hit tab now, boom, and I've just accepted that function. So what it's going to do is whenever this is called, it's going to do a digital read on the e-stop pin. The e-stop pin isn't even defined, like it does not exist, this def, and it sets GX direction to stop. Now there are good things and bad things about this. It is trying to figure out what my intent was based on the comment that I wrote. So I wrote stop all motors if the e-stop button is pressed, and it then created a function. It's assumed that I want to read an e-stop pin, which is fine. And it set GX direction to stop. Now it hasn't actually, this is not going to work because there is no e-stop pin. The other thing is, if it was a button with a pull-up, which is how I normally handle inputs, it would be if digital read e-stop pin equals low. So that should be reading a low instead of a high. It said, but it has done good things. GX direction, for example, is really a global variable. You can see it's got the G prefix in it. G_X_ direction equals stop. It has inferred from the rest of the code base that the GX direction variable tells the state machine, or it tells the motor movement code what movement it should be doing. So the state machine that is doing all of the movement. And it has set it to stop because it has found elsewhere in the code that the word stop is a state of that state machine. And yeah, so if you didn't understand enough about the code, you could just accept this and have problems and not understand what the problems are. So this is my approach to using AI for this sort of coding task at the moment, is that a whole lot of true believers think that you don't need to know how to code anymore, because all you have to do is describe what you want and the AI, the agent, whatever, the LLM, will generate the code for you. But certainly at the current level of development, that is not the case. You need to be paying very close attention to every line of code that it generates, because it'll do things like have the wrong level on sensing this, because it's tried to figure out what my intent was, but all I told it was this: stop all motors. It doesn't really know how it is trying to read my mind, and it didn't get it quite right. But it's a really good start. So what I've found is that this, using something like Cursor, is really useful for roughly fleshing something out and then going through and fixing little things so that it actually works the way I want it to work. Now, what I'll need to do in order to actually make this useful is I would need to add to chat. I would need to add check e-stop to the loop. Maybe it'll do that by itself. Maybe it won't. I don't know. So I'm just going to copy that function name, come back to the loop. Where's the loop? And let's make it the very first thing. And look at that. I haven't actually typed anything yet. All I did was put in enter to break a new line, and it's got check e-stop as the suggestion. So all I have to do is hit tab, boom, and now we have check e-stop in the main program loop. So yeah, you can kind of bumble your way through, and it'll make mostly sensible suggestions. It can save you a bunch of typing, because I've typed hardly anything to achieve this. In fact, what I could do now is if I come back up to, yeah, you can see here, this is where the LLM figured out that stop is the state that we need to set for movement. Now, if we do config.h, and okay, so we do not have an e-stop pin defined yet. I bet that now, so I'm in a different file now. I bet now that if I come down to this pin section and put in a new line, it is going to suggest an e-stop def. Let's see if it does. PCB sensors, drive motors. I'm just going to put it up. I'm going to put it up near the top. So I'm going to make a blank line there. E-stop button. Nice. Tab. And now what's it going to do? Okay, define e-stop pin 34. Tab. Cool. So I hit enter and tab twice, and I got the heading in the format that matches the rest of the code, and I got an e-stop pin definition, and it's just picked 34, which may have a conflict with something else. I mean, it has no idea. It doesn't know. All it's doing is looking at the code. It does not know what hardware it's running on. It's got, at the moment, it's got no way of introspecting the actual schematic. But of course, that is also possible. You can, with some, I keep changing terminology. I'm kind of just going to call it AI, even though that's debatable. With some AI, you can do things like upload a schematic and then say, explain to me how this circuit works. And it actually does a pretty decent job. Yeah, anyway. Oh, Jacksec said Copilot is local to VS Code now. Okay, cool. Wagonload says, I tell AI to write code fully documented REM statements, so if there's a bug, the REM statements would keep us on the same page. Okay. Pete says, telling an LLM to insert debug log entries at every state change within the function method class you're trying to fix is fairly safe. Tell them to do it, then go get a cuppa. Yeah. And Pete says, exactly, still need to learn to code, review any code generation. But for certain chores, it's a dream. Yeah, it is. Johnny says, I found it good at adding documentation to my code. Oh, that's cool. Amanda says, yes, it used to take a week to write the code and 4 weeks to debug. With AI, it takes 5 minutes to write the program and 4 months to debug. AI is great to write code snippets when you are stuck. Grant says, could have aligned up the numbers column. Oh, Pete says, use LLM. Okay, so, oh, Johnny says, this is like 90% AI generated, a library for Sion's Whopper. Johnny Bergdahl, GitHub. All right, let's bring this up. JB Whopper. Sounds like a hamburger. I'd like a JB Whopper, please, with extra cheese. Is a helper library for the Arduino platform that allows you to easily interface with the Unexpected Maker Whopper board. Oh, and for those of you who don't know what this is about, Whopper. So Unexpected Maker is Sion, obviously, who is often here in the chat and has his own YouTube channel. And Whopper is a display board, which is it's like a recreation of a thing from the movie War Games from many, many years ago. I think Whopper was the name of the computer in War Games. I haven't seen War Games since I was a kid. So yeah, but it had like some kind of display on the computer. So Sion did a reproduction of the Whopper. Installation, usage, yeah. Full code documentation, display related methods, main page, yeah, cool. Files, file members, oh, JBW effects, cool. Yeah, that's really interesting, Johnny. Good to see, good to see. Henrik said, let's add some electron source as well. Oh, Amanda said, Whopper stands for War Operations Planned Response. Would you like to play a game? Yes, I would like to play Thermonuclear War. That's a fun game. The stakes are low. The outcome doesn't matter to anyone. Where am I? Okay, so the thing is, I don't actually even have an e-stop. I should have an e-stop. So let's I am going backwards and forwards on whether I hit save on these files, because I've got 2 modified files here, and if I hit save, I now have a chunk of code in here, which is the check e-stop. So check e-stop. Where is it? Go to definition. So I have a check e-stop, which is going to be non-functional because the pin isn't defined, I think. Okay, so what's going on in my head is I am debating leaving these changes in, hitting save, leaving these changes in, maybe with a tiny mod. So I'll say if that is low, I'm going to make this so that the obvious things that are wrong are fixed. So I've fixed that. Now where do I do the pin defs? All right, I'm going to do pin mode. I'm going to do, let's see if it auto completes this. Look at this, pin mode, e-stop, pin input, pull up. Yep, hell yeah, I'll take that. And so now we have a pin defined here. We've got an e-stop pin. Let's align this. There we go. So at the moment it is pin 34, and I'm just going to add a note. Need to do this in hardware. Yeah. So at the moment it's going to be reading from pin 34. I don't even know if pin 34 is even vaguely sensible. Like if we, let's come back to here and have a look at IO34. Where is it? IO34? I think IO34 is probably not reasonable on an S3. If it was on an old style ESP32, then perhaps. Which reminds me, this code, the Conveyor 2 code, is currently running on an ESP32. So this is a premature change anyway, because this is new hardware, it's a new processor, all the pin assignments are going to change. What I need is a version of the PCB conveyor code with the ESP32 stuff in it. So what I'm going to do is go to cursor, and I'm going to 34. What is pin 34 on a normal ESP32, and is it conflicted? This is the thing, is if I commit this change now, what I'm doing is making a change which may break the existing conveyor controller. Yes. Oh, okay. Jackstech made a very good point. E-stop should never be in code unless it's a hardware interrupt that kills power. Otherwise, it's a cycle interrupt. I know it's pedantic, but in safety systems, that terminology matters. Yes, that is a very good point. So maybe what it should be is not an E-stop, but just a stop. So what we should do is have, yeah, you could have a stop button on the front. You could also have an E-stop, which kills power. So that would kill all the power. So say we brought in power to the conveyor, we should have an external E-stop connection. That is a very, very good point. So Austin says, cool thing with the S3, all GPIO pins can be configured as interrupts. Yes. However, what I am thinking of doing now that this has been raised, this is a really interesting point. This one thing could actually make this whole stream worthwhile from a progress point of view. Let's do this. I'm going to go to connectors. There was someone asked, what am I making? Nick said, what is he making? Mostly just making hot air. 3.81 millimeter, no, not with the 2 millimeter screw, 3.81 vertical, that'll do. Update, yes, update. Okay, so here's what I'm going to do. I am going to, do I have room? I need to make a little bit of room up here. I could compress that slightly, but what I'm going to do is, yeah, I could actually compress quite a lot. If I am sneaky about rearranging here. Okay, here is what I am going to do. I'm going to bring that to there. V in plus can go there. I'm going to do that. Net. V in plus. Okay, I'm just going to delete that. That is V in plus. So what I'm actually doing right now is adding a connector in series with the main power input that comes in from V in. So if I'm going to label that. No, but to seriously answer the question, I'm making a conveyor control system, and then I'm going to name that as V in plus. Yes, and I'm going to give this a value of E-stop. Okay, so that is a connector. Let's sort of neaten this up a little bit. Where are we? Alt move makes it nice and smooth. Let's put the name above the value. There we go. So this is now a 3.81 millimeter pluggable screw terminal, which is in series with the main V in line. So what I can do is two things. I can either have a plug straight into it with a jumper looping around, and that will just permanently enable power, or I could have an e-stop switch plugged into it. So e-stop switches are normally closed. You know, the big red hit the big red emergency button things. Those switches are normally closed. So when you pass power through it, when it's in its normal position, power passes through it, and your device is powered up. And then if you hit the switch, it compresses and latches down, and it breaks the circuit. So it stops power getting through to the destination. And with this connection in place, what we can do is we can have an external hardware e-stop that when you hit that switch, it will break the power connection, and then the conveyor will stop instantly. Like, no matter what it's doing, it won't have any power. It'll kill everything. It'll kill the microcontroller, it'll kill the motors, etc. So I could segregate it so that this only killed the motors, is one option. But I think for simplicity, I am just going to make it a kill everything switch. Now, oh yeah, we'll get back to that other schematic in a second. Save. All right. Does this... Wagonload says a 1/8 inch earphone plug wired to close when nothing is plugged into it. A relay could plug into it. Yeah, that's true. But the I like the little 3.81mm screw terminals. I use them on lots of things. So I've got boxes and boxes of them in all the different sizes, as in different numbers of connections. So, they're really convenient, because if you just want to loop around, all you do is you make a little Y loop and you screw it into the plug and then you plug it in. Or if you've got an external e-stop switch or whatever, you just screw it in. Very easy. It has all the good things about screw terminals combined with all the good things about a plug and socket, except for being physically bigger, which is a little downside, but acceptable. Now, it is already 11 o'clock. I am going to be stopping in a minute because I have so much cleaning up to do before people start arriving for the barbecue. And where are we? Okay, so what it's done is we've now added this. This is the, not that. This is the pluggable screw terminal, which will be the e-stop connection. So that needs to be bridged for the conveyor to run. Now, okay, other decisions to make. You will see, in fact, if we go back to this view, look at this. There are 5 IDC headers across the top. Those IDC headers are for the time of flight sensors that go to the that are the PCB sensors to detect when there is a board on the conveyor and where it's located. I made a change here, not on the stream, but after the last stream where I was talking about this. And I am now second guessing myself and thinking that I shouldn't have done it. I don't know. I just don't know. Pete, my face is a pluggable screw terminal? You're not plugging into my face, Pete. So, I feel like I need to draw, in fact, I am going to draw a diagram. Let's go to the whiteboard that isn't a whiteboard. Scroll across here. This is my PCB conveyor worksheet, short conveyor, long. Oh, this was just working out lengths because I'm going to do long, short, long between the output of the second pick and place machine and the reflow oven. That's going to make up a total of 1720 millimeters plus some little gaps in between them. So anyway, what else do I have on here? PCB sensor wiring. Ah, okay, this is actually relevant. So this was me working out cable lengths for the left, middle, and right sensors. So you can imagine that there is a, this is the front rail of the conveyor, and then it's got time of flight sensors left, middle, and right looking up to detect when the PCB is moving across it. So this is the configuration on the current arrangement. Now, there are two sizes. I'm going to draw the frame twice here. So there is the base chassis, and I'm going to do it twice because, oops, there are two different scenarios here in terms of sensors, and this is where I'm second guessing myself about whether I should have made this change. So on the short conveyor, what happens, well, no, the front rail is fixed. So the front rail is matched with the front of the chassis, and then the back rail moves. So it can move backwards and forwards. Now in the long one, it's the same. And the difference is that this one, what were those lengths? So 340 millimeters for a short conveyor, 690 millimeters for a long conveyor. So that's 340, that's 690. And then there is the back rail that can move forwards and backwards to adjust for handling different size circuit boards on the conveyor. Okay, so the way the short conveyor has been done is that I have a sensor here, and also this is assuming that we have a left to right direction of travel. So we've got a sensor here which is left, we've got a sensor here which is right, and we've got a sensor there which is middle. So LMR, that is, oops, not there. No, that was me doing all the calculations for figuring out motor gearbox ratios and things. So that is, oh yeah, it's on the same page right here. So left, middle, right. And on the existing controller, I've got three IDC connectors. One IDC connector that goes to each of these time of flight sensors. Now, the thing is that on the long conveyor, the entry sensor has to be out here. The exit sensor has to be here. There's no way around that. And then middle sensor is going to be here. M, L, R. So there is then a much bigger gap here between the middle sensor and the end sensor. And with the new design of the chassis, what I've done is integrated the left and right sensors into the corner pieces right here. So the piece of plastic, the 3D printed structure here and here that joins the chassis together has the sensors in it. All right, that leaves me with some options for the long one. I can either have a different piece of plastic, like a different 3D printed fitting that goes in here for the long conveyor that does not have the time of flight sensor in it, because the time of flight sensor has moved out to this location. Or I can use the same on both of them, and I can have a time of flight sensor here and here. So I would end up with 1, 2, 3, 4, 5. So I would have 5 board sensors on the long conveyor and 3 board sensors. So that might be 1. So if we take 1 as being the entry each time, 5 as being the exit each time. So we've got 1 and 5, and then the middle sensor could be 3. So it could be sensors 1, 3, and 5 on the short conveyor, and then we've got a couple of extra sensors on the long conveyor. Also left to right. So this is the thing, is I don't know if I should do these particular sensors. I've got to stop. It's after 11 and I've got so much to do. All right, let's just decide this, and then I'm going to go. Now, do I want 5 time of flight sensor inputs on the board? Oh, there's some yellow. out in the street on his horn. So we've got that was a joke, by the way. It's Crispian, I'm sure, out there. So do I want to have 5 time of flight sensors, or is it just useless? Like, why would I even have these extra 2 sensors? What I care about...
Said, Alexa, shut it all down.
It almost worked. So we definitely need the entry and exit sensors. We definitely need a middle sensor and to stop a board in the middle of the conveyor. Do we need these other sensors? I could just leave them off. I keep thinking myself into different scenarios. I'm leaning back towards taking them off and not having these ones here at all. So you can see that what I did was I added a couple of extra connections and I changed the numbering. So it used to be LMR and now it's sensor 1, sensor 2.
Alexa, turn off the lights.
You did it. How did that get past the
Okay.
How did that get past the capture, the prevention? I'm leave the brackets on, but no sensor just in case. Yeah. So I could put these connectors on the board. All it means is that there is extra. There are 2 extra GPIOs that I need, and it's extra space on the board, but I could do it. So I am very tempted to remove them though and just go back to 3 sensors, because the other thing is that it means I've got to special case the code. There's someone behind me. I've got to special case the code, because if it doesn't even have those sensors, it's not going to get any responses from them. And I think it's just going to end up with more complications. So I think that I'm going to delete the extra 2 sensors and just have 3. So I've got a consistent sensor structure and operational sequence regardless. Yes, it is, Henrik. I hit mute after Pete managed to turn off the lights. Yeah, Pete succeeded through the TTS right before you walked in the door. Yes. All right. So I am going to stop because I've got to start getting some stuff ready. As simple as possible, but no simpler, says some call it fun. Yeah. All right. I am going to go.
I am watching hairstyle.
Right. Thanks, Henrik. I both of us, I think. So thank you for coming along.
Man said, "Hello, Jono," and outside the box.
I hear me from the car. And I will see some of you soon, like in an hour and 17 minutes. And I will see many more of you next live stream. Austin just sent me a message. Payload project, yeah. Okay. That was in Discord though, so I will follow up with that a bit later, Austin. Thanks everybody for coming. Hooray! Hooray!